Okay, students, next chapter, polynomials. Third chapter, polynomials. So in that first definition, what is polynomial? A polynomial is an algebraic expression consisting of variables, coefficients, and operations of addition, subtraction, and multiplication, and non-negative integer exponents. So this is the definition of polynomial. What is meant by polynomial? So it is nothing but an algebraic expression. So that algebraic expression consists of some variables. So what is meant by variable? Variables are nothing but letters, alphabetic letters like x, y, z, coefficients, and the operations of addition, subtraction, multiplication, and non-negative. Non-negative means positive, only positive, not negative. Integer exponents, powers, their powers must be positive. Okay, right, that is called as polynomial. Right, next, what is the degree of the polynomial? Degree of the polynomial is nothing but the highest power of the variable in a given polynomial is called as degree of the polynomial. Okay, for example, if you take one polynomial, that is 3x cube plus 5x plus 9. So what is the degree of this polynomial? So the highest power of the variable. So here x is variable. Why? Because what I said, variable is nothing but letters of the alphabet. So here only one letter is there, that is x. So the variable power is 3. So the variable power, that is x power, is 3, and here the x power is 1. So whose power is more? This 3 is the more, no? Highest than 1. So therefore its degree is 3. Okay, so like this. So degree is nothing but the highest power of the variable in the given polynomial is called as degree of the polynomial. Okay, we have some different type of polynomials. First, zero polynomial. What is meant by zero polynomial? A polynomial of degree 0. A polynomial of degree 0 is called as zero polynomial. For example, you take numbers constant. These are constants. So these are the example, -7 and 3/2. So it is also one polynomial whose degree is 0, variable power 0, right? Next, linear polynomial. What is meant by linear polynomial? A polynomial having of degree 1, variable degree is 1, that is called as linear polynomial. Standard form of linear polynomial is ax plus b. So this is the standard form of linear polynomial, that is ax plus b. Example for this one, 5x plus 3. A is some value, number, and x is a variable and b is another number. Okay, you can write n number of examples. So why we are calling this as a linear polynomial? Because x is a variable whose degree, whose power or degree is 1. So that's why it is called as linear polynomial, and the standard form of linear polynomial is ax plus b. Okay, so next, quadratic polynomial. What is meant by quadratic polynomial? A polynomial whose degree is 2 is called as quadratic polynomial. So standard form of or general form of quadratic polynomial is ax square plus bx plus c. So that is example 3x square plus 5x plus 7. Observe here, variables highest power, that is square, next to x power 1, next constants. Highest power of variable, next least highest least power of the variable, and the last one is constants. So this is the example for quadratic polynomial: 3x square plus 5x plus 7, 9x square plus 7. So here you may get one doubt, sir, you have written ax square plus bx plus c. So you said that this is a standard form of quadratic polynomial, but here that x is not there. Yes, we can write, or we can consider this as also a quadratic polynomial. Quadratic polynomial, it may consist of x, sometimes it may, sometimes it may not. So if you take, this is a one example, that is it consists of square, x, and variable constant. Okay, but in this example here there is no x coefficients, x is not there, but x square coefficient is there and constants are there, but even though it is quadratic polynomial. Next one, here we have only 3y square. Of course it is also one quadratic polynomial. Okay, constant is not there and x coefficients are also not there, but it is one quadratic polynomial. Right. In the same way, next cubic polynomial. What is meant by cubic polynomial? A polynomial whose degree is 3 is called as cubic polynomial. What is the standard form or general form of cubic polynomial? It is nothing but ax cube plus bx square plus cx plus d. Okay. So, for example, we can write a, b, c, d are some values, just numbers. X cube, x square, x are variable. Okay. So, by using this, we can write 3x cube plus 2x square plus 5x minus 7. Okay. So, this is one example. X cube plus 7x plus 9, it is another example. X cube minus 2 is another example. 8x cube plus 5x. So, if you observe here, x cube is there, x square is there, x is there, and the last constant. But whereas in example 2, we have x cube, x square is not there, but even though it is cubic polynomial, x is there, x coefficients are there, and constant is here. In the next example, only x cube is given, x cube coefficients are given, and constant is there. X square coefficients and x coefficients are not there, but even though it is cubic polynomial. Next, last example, x cube coefficients are there and x coefficients are given, but constant and x square coefficients are not given, but even though it is cubic polynomial. So these are the definitions and examples of quadratic polynomial and cubic polynomial. Okay. Next question, students. Try this question. Write the general form of quadratic polynomial and a cubic polynomial in variable x. So our solution, what is our solution? General form of, just now I have written general form of a quadratic polynomial is a x square plus bx plus c. So this is the general form of quadratic polynomial, and general form of cubic polynomial is, we have to write ax cube plus bx square plus cx plus d. So this a is the coefficient of x cube and b is the coefficient of x square, c is the coefficient of x, and d is constant. Okay. So these are the standard forms of quadratic and cubic polynomials in variable x. Right. Okay, students. Next, try the second question. Write a general polynomial q of z of degree n with coefficients that are b0, b1, so on bn. What are the conditions on b0 to bn? Okay. So this is the representation that q of z is equal to b0 z power n plus b1 z power n minus 1 plus b2 z power n minus 2 so on bn minus 1 z plus bn is a polynomial of nth degree. So this is a representation of q of z of degree n, where b0, b1, b2 so on bn minus 1 comma bn are real coefficients and b0 is not equal to 0. So this is the answer for the second question. Next, do these questions. In the first one, if p of x is equal to x square minus 5x plus 6, then find the values of p of 0, p of 1, p of 2, p of 3, p of minus 1, p of minus 2, p of minus 3. So let us write the given polynomial. This is nothing but value of the polynomial. This type of questions are called as value of the polynomial, or find the value of the polynomial. If this is a polynomial, okay, and p of 1, p of 2, p of 3, p of minus 1, p of minus 2, p of minus 3, we have to find. Okay, so first you write given polynomial is represented by p of x is equal to x square minus 5x plus 6. So that is the given polynomial. Now we have to find p of 1. So what is p of 1? It's very simple. P of 1, wherever x is there, we have to substitute 1. So that is equal to p of 1 is equal to 1 square minus 5 into, in the place of x you write 1 plus 6. that is equal to 1 square is 1 minus 5 into 1 it is 5 plus 6. Now add the positive values. 1 is positive and 6 is positive. 1 plus 6 it is 7 minus negative value 5. So that is equal to 7 minus 5 is 2. Therefore P of 1 is equal to 2. So value of P of 1 is equal to 2. So this 2 is nothing but value of the polynomial. Next, now we have to find P of 2. What is P of 2? This is also simple. Now this time we have to substitute wherever x is there, we have to substitute 2. So that is, let me write the given polynomial, that is P of x is equal to x square minus 5x plus 6. So P of 2, in the place of x we are substituting 2, that is 2 square minus 5 into 2 plus 6. So P of 2 is equal to 2 square is 4 minus 5 to the 10 plus 6. So add the positive values. 4 plus 6 it is 10. Next negative value. 10 minus 10 it is 0. Therefore P of 2 is equal to 0. Next, what is the next one? P of x. Let me write the given polynomial, that is x square minus 5x plus 6. So this time we are going to find the value of 3. That is P of 3 is equal to 3 square minus 5 into 3 plus 6. Or P of 3 is equal to 9 minus 5 3 is 15 plus 6. Add the positive values. 9 plus 6 it is 15. 15 minus 15 and that is equal to 0. In the same way, next P of x, write the given polynomial, that is x square minus 5x plus 6. Now write the value of P of minus 1. So P of minus 1 is equal to minus 1 whole square minus 5 into minus 1 plus 6. So wherever x, you have to substitute minus 1. So P of minus 1 is equal to minus 1 square is minus into minus plus 1 into 1 it is 1. So minus into minus plus 5 ones are 5 plus 6. Now add all those values, that is P of minus 1 is equal to 1 plus 5 6, 6 plus 6 it is 12. So P of minus 1 is equal to 12. Next, P of x is equal to x square minus 5x plus 6. Now substitute the value of minus 2 or find the value of minus 2, P of minus 2. Wherever x is there, you substitute minus 2, that is minus 2 whole square minus 5 into minus 2 plus 6. P of minus 2 is equal to minus 2 square is 4. Minus into minus plus 2 into 2 it's 4. So minus into minus plus 5 2s are 10 plus 6. Now all are positive, just to add up. So sum up 4 plus 10 it is 14. 14 plus 6 it is 20. So P of minus 2 is equal to 20. Next, P of x is equal to given polynomial x square minus 5x plus 6. Okay. Now, which value we have to find? P of minus 3. That is P of minus 3 is equal to minus 3 square minus 5 into minus 3 plus 6. P of minus 3 is equal to minus 3 square is 9. Minus into minus plus 5 3 is 15 plus 6. So P of minus 3 is equal to 9 plus 6 it is 15. 15 plus 15 is 30. So this is the way of finding the values of the given polynomial. Okay. Okay, next second question from the do these questions. If P of m is equal to m square minus 3m plus 1, then find the value of P of 1 and P of minus 1. So let us write the solution. So given P of m is equal to m square minus 3m plus 1. Now we have to find the value of P of 1. So wherever m is there, we have to substitute plus 1. That is 1 square minus 3m. In the place of m, we are writing 1 plus 1. So P of 1 is equal to 1 square is 1 minus 3 ones are 3 plus 1. Add the positive values. This is a positive value and this is a positive value. That is 1 plus 1, it is 2 minus negative value. This 3. Therefore, P of 1 is equal to 2 minus 1, 2 minus 3. It is minus 1. So P of 1 is equal to minus 1. In the same way, let me write the given polynomial, that is P of m is equal to m square minus 3m plus 1. Now we have to find P of minus 1, that is P of minus 1 is equal to negative value minus 1 whole square minus 3 into, in the place of m, write minus 1 plus 1. So P of minus 1 is equal to minus 1 square is minus into minus plus 1 into 1 is 1. Minus into minus plus 3 ones are 3 plus 1. So P of minus 1 is equal to 1 plus 3, 4, 4 plus 1, it is 5. So P of minus 1 is equal to 5 and P of 1 is equal to minus 1. So these are the values of given polynomial. Okay, students, next to do these questions. In that first one, let P of x is equal to x square minus 4x plus 3. Find the value of P of 0, P of 1, P of 2, P of 3 and obtain zeros of the polynomial P of x. Okay, two questions are given in single question. So let us write solution given P of x is equal to x square minus 4x plus 3. Okay, what we have to find? We have to find P of 0. So wherever x is there, you substitute 0. 0 square minus 4 into 0 plus 3. So P of 0 is equal to 0 minus 4 into 0 is 0 plus 3. So P of 0 is equal to just 3. Next, P of 1. So directly I'm substituting here, wherever x is there, you substitute 1, that is 1 square minus 4 into, in the place of x, it is 1 plus 3. So P of 1 is equal to 1 square is 1 minus 4 ones are 4 plus 3. So P of 1 is equal to positive values are 1 plus 3, it is 4 minus negative values are 4. So P of 1 is equal to 4 minus 4, it is 0. Next, P of 2. So what we have to find next value? P of 2. So P of 2 is equal to x square, that is 2 square minus 4 into x is 2 plus 3. So P of 2 is equal to 2 square is 4 minus 4 2 is 8 plus 3. So P of 2 is equal to positive value is 4 plus 3, it is 7 minus negative value 8. So P of 2 is equal to minus 1. So in the same way, next we have to find P of 3, that is equal to x square, it is nothing but 3 square minus 4x, 4 into 3 plus 3. So P of 3 is equal to 3 square is 9 minus 4 3 is 12 plus 3. So positive value is 9 plus 3, that is equal to 12. 12 minus 12. So P of 3 is equal to 0. So this is the way of finding the values of the given polynomial. Okay. So this is the way of finding values of the given polynomial. Okay. Now you observe here, when we substituted, or what is the value of P of 0? It is 3. What is the value of P of 1? It is 0. Yes or no? So value of P of 1 is equal to 0 and value of P of 2 is equal to minus 1. Next, value of P of 3 is equal to 0. Whenever we substitute the given value in the given polynomial and if we get the answer 0, so in two cases we got 0, that is P of 1 is equal to 0 and P of 3 is equal to 0. Therefore, we can say that 1 and 3, this 1 and this 3 are the zeros, of given polynomial. Given polynomial P of x is equal to, what is that? X square minus 4x plus 3. So are you getting what I said? After finding the values of the polynomial, wherever you get the zeros, that is here we are getting P of 0, P of 1 is equal to 0 and in this case we are getting P of 3 is equal to 0. Then we can say that this 1 and 3 are the zeros of the given polynomial. Okay? Okay, students, next question in the same do these questions. Second one, check whether minus 3 and plus 3 are the zeros of the polynomial x square minus 9. Okay, first of all, we have to write solution in that given. What is given polynomial? Polynomial P of x is equal to x square minus 9. So this is a given polynomial. Now we have to check. Now we have to check whether minus 3 and plus 3 are zeros of polynomial p of x or not. Okay, now we have to check whether plus 3, minus 3 and plus 3 are the zeros of the given polynomial, that is p of x is equal to x square minus 9 or not. Okay, it's very simple. So whatever these values are given, no, that values you have to substitute in the given polynomial. So that is p of x is equal to, it is x square minus 9. Now I'm substituting in the place of x, it is minus 3, that is equal to minus 3 whole square minus 9. So p of minus 3 is equal to minus 3 whole square, we write as minus 3 into minus 3. So minus into minus, it becomes plus 3 into 3, it is 9. So it is positive 9 minus negative 9. So positive 9 and negative 9, it is 9 minus 9, it is equal to 0. Okay. So p of minus 3 is equal to 0. Next, we have to substitute p of 3 plus 3. Wherever x is there, you substitute 3, that is 3 square minus 9. So p of 3 is equal to 3 square is 9. 3 3s are 9 minus 9. So p of 3 is equal to 0. So when we substituted p of minus 3, we got answer 0. In the same way, when we substitute in the place of x, that is p of 3 is equal to 0. So therefore, whenever we substitute the values, given values in the given polynomial, and if it is equal to 0, then we can say that these values are nothing but the zeros. That is, therefore we can say that minus 3 and plus 3 are the zeros of given polynomial. Given polynomial p of x is equal to x square minus 9. So this is the way of finding or checking the given values as zeros or not. Okay, right.